Hello everyone, my name is Eric Severy and this is my second video for the computational science training tutorial that I'm creating. This video is going to be focused on just a quick overview of the different languages that we're using. For this course we're going to be using Python, Matlab, and C++, because I think those are three good languages to compare because they all do similar things in a very different way. First, I want to talk about what they have in common. They're all well maintained, they're all effective, they're all commonly used, and they all meet industry standards. They're all really good languages. So I'm really going to kind of focus on the differences here. So when I talk about the advantages and disadvantages, even the disadvantages really aren't always that bad. They just might mean there's a learning curve or there's a challenge to entry. So with Python, some of the advantages are it's an interpreted language. What that means is the language will run through an interpreter. And what it really means is all Python programs will run equally well on all machines. Now, occasionally that's not true because of libraries, but Python's easy to learn. There are many packages that are available. NumPy is really good for numerical stuff, and Matlab is really good for graphs and things like that. Python is great when you want quick code for daily tasks. I think it's the best language for that. It's also free and open source, so there's no costs associated with it. Now, some of the disadvantages with Python are that it is interpreted. Being interpreted is both an advantage and disadvantage. It means it'll run well on all machines, but it will be slower. It does require the interpreter software, and if you have a machine that can't have the interpreter, it might not work. The way that Python works, it can be very difficult to manage how types work in the programming language. Types work differently in Python than C++. So if you have code that relies heavily on typing, there's going to be some workarounds, and your code becomes more difficult as you require more type dependency. Also with Python, low-level programming is difficult. It's really hard to access the base features of your computer, whereas in C++ it might be easier. Also, Python is not common on supercomputers. If you're doing high-performance computing, Python is not often designed for that. All right, so that's kind of where Python sits. Matlab, its main advantage is it is an all-in-one package. It's very easy. It's great for visualization. It has native matrix and vectors built in. In fact, Matlab means matrix laboratory. Matlab has a very mathematical interface. It's fast, and it plays well with others. What I mean by that is there are actually things in Matlab that allow you to output C and C++ code from your Matlab code. Now, that's a little difficult to do, but it can be done. So Matlab's a great interface. Some of the disadvantages, Matlab is not free. It is really designed for math and science only. So if you're working on a project where you're trying to figure out word frequencies, Matlab might not be a good language for that. It's not designed for language analysis as much as it is for math and science. Matlab is probably not going to be on a supercomputer or a cluster, so if you need to do large-scale computing, it's not going to be so good for that. And I've found low-level programming to be difficult. So that's just a quick overview of Matlab. C++, it is a compiled language, so it's going to be faster. It's very powerful. You have easy access to low-level features of your computer. It's based around object-oriented design. And then for extra libraries, you have the standard template library and the boost libraries. And these are really going to be how you're going to bring a lot of the Matlab and like matrix functionality into C++. Some of the disadvantages of C++ are that it is compiled, which means you have to use a compiler. You have to link, and then you have to deal with compiler and linker errors if there's a problem in your code. It's slower to learn, I think, at first. And there's more steps before a program can run. So C++, there's a little learning curve just to get your program going, but once you get past some of those, I think things kind of sort themselves out. So what we're going to learn in the early lessons, we're going to really learn how to use Python, and that means we're going to take a quick look at the interpreter. We're going to look at the interactive interface, running a Python program in a file, and looking at different IDEs. Really, what's going to happen is I'm going to show you quickly how the interpreter works. It's kind of nice for spitballing stuff. I'm going to show you how you can create your files, and then I'm going to show you the IDE that I use. An IDE is just the development environment. IDE, I think it stands for Independent integrated development environment, and that allows you to create your file and run everything and manage the debugging all in one. For C++, we're going to look at compiling, some of the compiler options, how we run, and then I'm going to show you the IDE that I use for C++. I might make a video just about some common C++ IDEs because everyone has their favorite. And then for Matlab, we're going to look at using the Matlab interpreter, running programs from files, and using the Matlab IDE. So for Matlab and Python, we can use an interactive mode, or we can run it from a file, and we'll look at both ways. In C++, we really just only have the compiling and running because it's not interpreted. All right, so that's what we're going to be doing in this course. Thank you for your time.